So this lesson on factoring adds an additional thing that we need to be able to do, which is factoring out the greatest common factor. And the greatest common factor is sometimes called the GCF, greatest common factor. Okay, so there are some that, like example one, that it's not too crazy hard to figure it out. So we are looking at 12K and 18, and we want to know if there is a common factor. And if there is, we want to find the greatest common factor. So I'm going to go to my factor sheet, and I'm going to look at 12, and I'm going to look at 18. Okay, so right now, I just care about the factors of 12 and the factors of 18. Now, what we want to do is find the greatest number that's a factor that they have in common. So when you look at those numbers, the greatest they have in common is 6. So what we're going to do is factor out a 6. And when you do that, you write it outside of a set of parentheses. And it's the reverse of the distributive property. And so for the distributive property, you multiply. So when you're factoring out a common factor, you're going to divide. So you take 12K and divide it by 6, and you get 2K. And then take negative 18 and divide it by 6, and you get negative 3. All right. Now, what makes this more difficult is when you have one like 2, where you have variables. So we're still going to do the common factors with numbers just like what we did. We're going to look at the factors of 40 and the factors of 64 and see the greatest that they have in common. So here are the factors of 40. I don't know if I can get them all in the same. Yeah, sure. All right. So here are the factors of 40, and here are the factors of 64. So we want to find the greatest number they have in common, which is going to be 8. So we're definitely going to factor out an 8. But there's other things in common. So both of those also have an x and a y. So we're going to factor out an x and a y. And then what we want to do is choose the smallest exponent. So on the x's, we have 8 and 4. The smallest is 4. And on the y's, they're both the same. It's just y. So all we can factor out is a y. All right. And then don't forget, you're dividing each of these by the greatest common factor. So 40 divided by 8 is 5. And then when we are factoring or dividing exponents, so like variables, x to the 8th divided by x to the 4th, what you're going to do is subtract the exponents. So that's going to be x to the 4th. Right? And then when I factor a y out of a y, that basically becomes 1, or just 1, which we don't need to write. Sorry. The y completely factors out. So there's no y in this term. All right, and we'll do the same thing again for 64 x to the 4th y. So we divide 64 by 8, which is 8. I'm going to factor out x to the 4th from x to the 4th. So it completely factors out, and there's no x left. And I'm going to factor a y out of a y, so it completely factors out, and there's no y either. Okay, so let's look at this one. If we're looking at the numbers between a common factor for 14, 35, and 7 is going to be 7. And then, and they all have an m, so we're going to factor out an m, and then we're going to choose the smallest exponent to factor out. All right, and then we'll divide each of those by 7m squared. So 14 divided by 7 is 2. m to the 6th divided by m to the 2nd, we are subtracting the exponents. It's going to be m to the 4th. Okay. And then the next term, we divide, and we're going to get 5. Subtract the exponents. It's going to be m to the 1st power, or just m. And then negative 7m squared divided by 7m squared is just going to leave you with negative 1. So if it all factors out, then you do have to put a 1 there. So we know we've factored out a common factor correctly if you can multiply this back out and get this. All right, one more of these, and we're going to practice some more trinomials. All right, so we're looking at the numbers. There is no common factor except for 1 between 3, 5, and 8. So we can't factor out a number, but they all have an A and they all have a B. And the smallest exponent for A is a 1, and the smallest exponent for B is a 1. So we're going to factor out AB. All right, so the 3, because we're not factoring out a number, the 3 is not going to change. We're going to factor out one of the A's, which in this case is not going to leave you with any A's, so no A's. Factor out one of the B's, so that's going to just have B left over, 3B. All right, then the 5 doesn't change. We're going to factor 1A out of A squared, it's going to leave you with A. Then we're going to factor a B out of a B, and that leaves you with no B's. And we still have 8. And then when you factor AB out of AB, you're not left with any A's or B's, so it's just 8. All right, and then for this last one, or these last set of examples, is factoring like we did the previous lesson, except we need to check to see if there's a greatest common factor first. So let's just look at these and just make that decision now. So for there to be a number that's the greatest common factor, every term would have to have a number. And if you look at 5 through 9, none of those very first terms have a number. So there's not a number to factor out. And if there wasn't a variable to factor out, they would all have to have a variable. And if you look at all of those, 5 through 10, there's not a variable in the very last term. So those don't have a common factor. However, on 11 and 12, there is a number in each term. So it's possible that I can have a common factor. So we need to just look at the terms and check. And so number 11, there is a common factor of 2. So we're going to factor out a 2. So we're going to divide each term by 2. Oops. Okay. And then this is a case where you can factor that again, just like what we learned yesterday or the previous day. So once we factor that 2 out, we don't look at this anymore. We're looking at these numbers. We want to multiply to get 20, negative 20, and add to get 8. All right, so to get k squared, it is going to be k and k. So we have other variables besides just x. And then if I multiply and get a negative, I automatically know one's a plus and one's a minus. And then you're going to go to your chart for 20. And we're looking for numbers that multiply to get 20 and add or technically subtract to get the negative 8. And that is going to be 2 and 10. Now, because I want a negative 8, I want the bigger number to be negative. So I can get a negative 8. Right? So that's it. So it's a little extra step at the beginning and then doing the exact same thing we did previously. All right, same thing here. There is a common factor of 5, and I would need to factor that out first. And then that 5 is just going to hang out in the front. And I'm going to use my rules for factoring this. I don't go back to these numbers. I focus on multiplying to get 6 and adding to get 5. Now, because this last term is a plus, I know my signs are the same, and they're going to be whatever that 5 is, which is 2 negatives. So 2 negatives multiply to get a positive and add to get a negative. All right, and then to multiply to get 6 and add to get 5 is going to be 2 and 3. Okay. Now, we're still going to have problems like before where there's not a common factor. So let's do number 5 together. All right. So to get x squared, I know it's x and x. I want to multiply to get 45 and add to get 14. And so because these are pluses, I know these are going to also be addition. So multiply to get 45 and add to get 14. Let's check out what multiplies to get 45. So these numbers multiply to get 45. The only pair of those that add to give us 14 is going to be 5 and 9. Okay, so let's do 7 and 9 together. So on 7, we already decided there wasn't a common factor, so we can go ahead and start factoring it. To get c squared, it's going to be c and c. I know if this is a minus that my signs are different. One plus, one minus. And then I also know that when I add, I get a positive 2, so I need the bigger number to be the positive number. So I'm going to scroll and look at 48. We're going to multiply to get 48, and the signs are different, so we're going to subtract to get 2. So there are several pairs of numbers that multiply to get 48. The only pair that's going to subtract to give you 2 are 6 and 8. Now we have to be careful where we put which. So we said that we want the bigger one to be positive, so it's going to be a plus 8 and a minus 6. All right, and then for this one, I know I'm going to multiply and get positive, add to get positive, so it has to be positive, positive. And then I want to multiply to get 36 and add to get 12. Those are our options. And the pair that adds to give you 12 is 6 and 6. All right. And then I just want you to know that on a multiple choice test, it's possible that when it's something times itself, it could be written as that thing squared. All right. And then for your assignment today, you have 14 factoring problems to do. Some of them have a common factor, some of them don't. So it could be like any of these that we did 1 through 12 1 through 12 today. It could be like any of them. So you have to pay attention to the common factors.